Alright guys, today we're going to make a lemon battery, and we're going to use lemon batteries to power an LED light bulb, and we're also going to use it to power a calculator, which you have right here. Now first of all, let me just show you a little bit about how a lemon battery works and how it's very similar to the batteries that we use for everyday electronics. Now all you need is something like a lemon or a lime that has citric acid in it. The acid's very important. You're going to put two different type of metals. What we use today is going to be zinc. This is a zinc coated nail, and then we have some thick copper wire here. And what happens is when you put these metals in acid, there's always going to be one that's more willing to release its electrons and one that's more willing to accept electrons. So here zinc is going to release its electrons, and they're going to flow from the area of high concentration to low concentration, and that flow is going to be what generates our electric current. Now one lemon battery equals about 0.9 volts. A AA battery is about 1.5 volts. So you could say that a lemon battery is about, has about half the energy of a AA battery, so you can use about two of them. And if you look down here, AA battery works like this. You have a little barrier here. The electrons in this side, they want to flow from here to here. You need a wire to connect it. So when there's no wire, your batteries are being stored and they maintain their voltage. Now, the great thing about an LED, which is a light emitting diode, is that it's a low energy bulb. It has a positive terminal and a negative terminal. Usually the negative terminal has a little flat part to it, so you know that it's a negative side. And you want to make sure that you hook it up properly when you're doing an electric circuit. Now let's go down here, and I have already assembled an electric circuit with 4 lemon batteries. And each one being about 0.9 volts, we have about 3.5 volts here in this circuit, and that should be plenty enough to power this LED light. One thing I wanted to point out is that these batteries have to go from their negative terminal, their negative electrode, to the positive electrode, and again, negative to positive, negative to positive. They have to all go in the same direction for the circuit to work. Alright, just like with batteries, they have to all point in the same direction for the current to flow through the circuit. Now what I'm going to do is I'm going to hook up the batteries to the LED bulb, and we'll see if we can power this baby up. Alright, check it out. It works. Alright, if I was to reverse this, it would not turn on. As we could see there, it doesn't work. So it's very important. I don't want you to think that if you try this at home and you can't get it to light up that your bulb's not working. You just have to reverse it. Okay? The next thing we're going to try is a calculator. And what I did is I removed, it has a backup battery in case there's no solar power coming, but I covered up the solar panel, and I just took these 2 wires and just hooked them up to the metal on each side of the calculator. So what we're going to do is we're going to see if we can power this calculator up with the lemon battery after disabling the solar panel and the little 3-volt battery that was in there. So we'll just hook this up. And I'll put my fingers back here to make sure the connection's working. Oh, there we go. And as you can see, it works. Can you zoom in on that? You see that? Oh. Let's see. The connection's a little weak, but you can get it to work. So you can do all sorts of mathematical calculations and stuff powered by the battery. Oh, let me see if I can. Alright. But it works. You only need a few volts to generate energy for one of these small calculators. It's pretty cool. You guys can try it at home. All you need is a lemon, 2 types of metal. You could use galvanized nails you get in the hardware store, and you can even use copper pennies that are made before 1982. because they have more copper in them and they'll work a lot better. So go ahead, try it at home, and that's how we can make batteries.